Okay, guys, I want us to look at the general solution. But before we start with the general solution, let us remind each other on the identities. So I will say bucket of identities. Bucket of identities. When you're dealing with trigonometry, you must know some few identities. There are certain identities that you need to know. So even before we start with the general solution, let us look at some identities that we need in trigonometry. So I will say bucket of identities for grade 10 and 11. These are the identities that we find from grade 10 and what? Grade 11. I'm sure you know, you are aware of these identities that I will be talking about. I'm just going to remind you, but I believe you know them. The first one is a square identity. It's a square identity. So we are looking at some identities. Give me the square identity. Okay. Anyone square identity? These are the identities that we must be aware of when we are dealing with trigonometry. Square identity, it's what? Sine squared x plus cos squared x equals to 1. You remember it, right? Okay? It is a square identity. We need it when we are dealing with problems of trigonometry. Again, sine squared x plus what? Sine squared x plus cos squared x, it's 1. This is our square identity. So, all the time, when we see sine squared x plus cos squared x, we have a right to substitute it with what? With 1. So we are looking at some identities. Now, this identity, we can manipulate it. We can do something to this identity. We can do some algebraic manipulations. If we manipulate our square identity, we can say sine squared x, we take cos squared x to the right hand side. Okay? We can say sine squared x is what? It's 1 minus cos squared x. Which means that when you see 1 minus cos squared x, you have a right to substitute it with what? With sine squared x. Sine squared x, 1 minus cos squared x. And what else do we know? We also know that cos squared x is 1 minus what? Sine squared x. These are the identities that you must know as a grade 12 student. Again, so that they will enable you to work with what? With trigonometry. It's going to be easy when you are dealing with trigonometry when you have these identities. Another one is what? We talked about the square identity. Another one is quotient identity. Quotient identity. Quotient identity. What does the quotient identity say? What is the quotient identity? Tan x, please write these identities down. If you are struggling with trigonometry, you need to know these identities. Tan x is equals to what? Sin x over cos x. It is called what? A quotient identity. Now, most of the time, when we see the trig ratio tan, we normally substitute it with what? With sine over cos. Tan x It's sine over cos. So when you see tan, you can normally substitute it with sine over cos. You can say tan is what? Sine over cos. It is what? A quotient identity. The identity because what is on the left is equivalent to what is on the right. So these are the identities that we pick from grade 10 and grade 11. Again, remember your identities. Now, if when we go to grade 12, we notice that we have some identities as well. We have got this identity. We have what we call sine 2x. And when we see sine of 2x, what comes to our mind? A double angle of sine. And it's clear that my angle x, it is twice. So this is what? A double angle. And you must know that sine 2x is equals to something. So we are now observing the identities from grade 12. You don't see this in grade 11 and grade 10. Which means I guarantee you that you are going to meet it in your final exam. Because we are now focusing on grade 12. You have to know what is sine 2x as a grade 12 student. We are dealing with what? Double angle identity of what? Of sine. There is only sine 2x in this expression it king 2 sine x cos x. So most of the time when you see sine 2x, you're going to substitute it with what? With 2 sine x cos x. Most of the time, when you see sine 2x, you substitute it with what? 2 sine x cos x. Sine 2x elekananengi 2 sine x cos x. These are the identities. What is on the left is equivalent to what is on the right. So this is a double angle identity. Let me just say GA of trig sine. The double angle identity of a trig ratio sine. Now let's go to cos. Cos 2x. We are still going to talk about what? The double angle identity. But this time around, we are focusing at what? At cos. So we must know the double angle identity of cos. And yesterday we said this cos is equivalent to 3 guys. This cos 2x is equivalent to 3 guys. One, it's cos squared x minus sine squared x. Actually, during my grade 12, this is the only identity I was using. When I see cos 2x, I was substituting cos squared x minus sine squared x. And I will still get to the correct answer. This is a very powerful identity. Cos 2x is equivalent to cos squared x minus sine squared x. If you have to forget among these three, don't forget this one. Cos 2x is equivalent to what? Cos squared x minus what? Sine squared x. This is the double angle identity of what? Of cos. Actually, to be honest, even now, in my mind, the only identity that I know right now, like that I can give you right now without thinking too much, is this one. The other ones, I don't know if you say give me the one of sine, maybe I forgot it. I only know cos squared x minus sine squared x. Why? Because I know that the other ones, if I need them, I can find them so easy. I can find them so easy. If I substitute cos squared x, cos squared x, q1 minus sine squared x. If I substitute cos squared x with 1 minus sine squared x, I will have what? 1 minus 2 sine squared x. So now I know what cos 2x is equals to 1 minus 2 sine squared x. It's not there. I am working it out. So that's why actually there is no need for me to I'm not storing it somewhere because I can work it out. If I need it, I can be able to work it out. Even cos 2x, even if I substitute sine squared x, sine squared x, q1 minus cos squared x. Even if I substitute sine squared x with 1 minus cos squared x, I will end up having 2 cos squared x minus 1. Cos 2x is equivalent to all these three guys. 1, 2, 3. So these are the identities that we need. We need the double angle identity. We need, double angle identity of sine. We need double angle identity of what? Of cos. Another identities that you need is the ones for compound angles. You also need a compound angle identity. But we'll talk about it sometime. Let's keep it aside a bit. Now, let's get to the point. I said our class will focus on what? On the general solution. So I want us to work out this problem. 5 tan theta minus 6 cos theta equals to 0. Make sure that you are writing it down. And the question is, determine the general solution. The question is as keys. Determine what? The general solution. Determine the general solution. Let me give you a tip. My first tip. When you are working with general solution, my first tip, try by all means to have a single trig ratio if possible. Try by all means on your equation, try by all means to have a single trigonometric ratio. How many trig ratios do we see there on our equation? 2. Again, we see the trig ratio tan, and we also see what? The trig ratio what? Cos. But our goal most of the time is to have one trig ratio. So I'm going to try by all means to have a single trigonometric ratio. So now, the first thing that I will do, I will look in the bucket of my identities. You go to that bucket of identities, you pick one that can help you there. Which identity can help us? It's a quotient identity. We said tan of x is sine x over cos x. So we can change this trig ratio tan using a quotient identity. We can have what? 5 sine theta over cos theta. I only change tan theta. Yesterday I said don't say 5 sine theta over 5 cos theta. 5 is only appearing once. You only change tan. It's sine over cos minus 6 cos theta is equals to what? 0. Okay, so I used the identity which is called the quotient identity. But now I must keep the skill of algebra with me. I must remember all the algebraic skills. So we will need, another thing that we will need is the algebraic skills. You must have some skills of algebra, such as multiplying two fractions. You need to know how to multiply two fractions. A over B times C over D. What does it become? It becomes AC over BD. Multiplying two fractions is the simplest thing that you can do in maths. You just multiply the numerators together and you multiply what? Denominators together. So you will need to know how to multiply fractions. Not only multiplication of fractions, you will also need to know how to add fractions. And this is where I want you to be very careful. Adding of fractions might be there in your exam. So you will need to know, how do I add two different what? Fractions. Okay, we'll come back to that. This is 5 sine theta over cos theta. 5 here go 11 obviously 1. 5 is the same as 5 over 1. So I can multiply 5 with sine theta. It's 5 sine theta 1 times cos theta minus 6 cos theta equals to 0. So I'm dealing with algebra. This algebra, you need to know how to multiply fractions and how to add what? Not only add, but also to subtract. You also need how to subtract the fractions. So, our level renal fraction she yamato 5 sine theta over cos theta minus 6 cos theta. This 6 cos theta, you can see it as 6 cos theta over 1. So I want us to focus on the left only. On the left only, pay attention. You've got two fractions on the left. You want to subtract these two fractions. You can only subtract if the denominator is the same. A very important skill in maths. You only subtract two fractions if the denominator is the same. Now, I see that here, my denominator is cos theta. So I'm going to say 5 sine theta over cos theta minus, I'm going to multiply this one underneath by cos theta, so that my fractions have the same denominator. Do you see the goal? Because I want to subtract these two guys, I can only subtract if the denominator is the same. So I'm multiplying 1 by cos theta, and what I'm doing to the denominator, I must also do to the numerator. Let's say you've got a number like this, 8. Let me say 8 over 2. We all know what 8 over 2, it's 4. Okay? Let's say suppose I multiply this expression, the numerator by 3, and the denominator also by what? By 3. What do you think will happen to my final answer? Will it change? 8 over 2 is 4. Let's multiply the numerator by 3 and also denominator by what? By 3. What will be my final answer? It will still be what? 4. Again, if you do something to the numerator and you also do it to the denominator, the final result will not change. It's like you are not hearing me. 8 over 2 is 4. So I'm asking you, what would happen if you multiply 8 by 3 and also 2 by 3? Your answer will still be what? 4. It won't change. So this is what I'm doing to 6 cos theta. I'm multiplying to the denominator by cos theta, and also to the numerator I'm multiplying by what? By cos theta. Why am I doing this? Because I want cos theta on the denominator. I want the denominator to be what? The same. So on top I'm going to have 6 cos squared theta equals to 0. Now I have a right to subtract the numerators. Why? Because the denominator is the same. So you have got 5 sine theta minus 6 cos squared theta all over cos theta equals to what? 0. Now you can do what? You can do cross multiplication again. You're going to end up with what? With 5 sine theta minus 6 cos squared theta equals to what? 0. Okay. Let me go back to this part. Let me go back to that problem. You know what I want to do? I want to multiply every term now by cos theta. Let me just say I have this. Let me multiply everything by cos theta. If you multiply 5 sine theta over cos theta by cos theta, you are going to be left with 5 sine theta. If you multiply 6 cos theta by cos theta, you are going to have 6 cos squared theta. If you multiply 0 by cos theta, you are going to have what? 0. Again? I just complicated a bit at first because I want you to know how to add and subtract what? Fractions. But if you multiply throughout, actually when you are dealing with the equations, when you are dealing with equations, let's say you have got x over 2 minus 3x equals to 4. When you are dealing with the equations, you don't want the denominator. So you can multiply denominator out to 2. You can multiply every guy by 2, every guy by 2, every guy by 2, so that this 2 cancel this 2. When you are working with equations, you just have to find a way of eliminating what? The denominator. I'm hoping you are not confused. Okay, let's focus here. Focus on this expression. 5 sine theta minus 6 cos squared theta. How many trig ratios do you have there? Look at 5 sine theta minus 6 cos squared theta. How many trig ratios do you have there? Huh? You can't count trig ratios, guys. Huh? How many trig ratios do you have? It's 2 again. And I said the goal is to have what? 1 trigonometric ratio. When you are dealing with a general solution, you wish by all means to have 1 trig ratio. So you can substitute cos squared theta. You can turn it into sine. Cos squared theta, you can turn into what? Sine. You can say 5 sine theta minus 6. You substitute cos squared theta into 1 minus sine squared theta. Why are you doing this? You do this so that you can have what? 1 trigonometric ratio. In this case, what is going to be a single trig ratio? Sine. We started with sine and cos, but after substituting cos squared theta, with 1 minus sine squared theta. Now we have got the same trig ratio, which is sine. Just write with me so that you can be able to practice. 5 sine theta minus 6, distributive law now. Negative 6 times 1 is negative 6. Negative 6 times negative sine squared theta is positive 6 sine squared theta equals to 0. Okay, let's continue with the problem. We now need, I said you need algebraic skills, again. You are now going to work with a quadratic. Yeah, that's why you guys, sorry. Okay, sharp. I am saying we have to continue with, remember I said we always have to check our algebraic skills. Again, some problems we need to use the skills of what? Algebra. So if you look at this expression, it's a quadratic equation. We can write it as what? 6 sine squared theta plus 5 sine theta minus 6 equals to 0. It's a quadratic equation. If you remember a quadratic equation, that is a quadratic equation. So what is my A? My A is 6. What is my B? My B is 5. What is my C? My C is negative 6. So we can now use a quadratic formula. But when you are using a quadratic formula, pay attention. You are not going to say x equals to. That is not the quadratic equation of x. We don't have variable x there. That is a quadratic equation of a trig ratio. So we are going to say sine theta equals to. You use a quadratic formula the same way, but you don't say x equals to. So you say minus b plus or minus b squared minus 4ac all over 2a. Sine theta equals to negative, you substitute your b, again. Your b is how much? It's 5. 5 squared minus 4, how much is your a? 6. How much is your c? Negative 6. All over 2 into your a is how much? 6. Now, let us focus on the right hand side. Tell me what do we get on the right? Let's use positive sign first. Then we will use negative later. So you say minus 5 plus, you put everything as it is on your cashew. You tell me how much you get on the right hand side. When you substitute that on your cashew, how much you get? Huh? With a positive sign, eh? So you say sine theta is equals to 2 over 3. Or now you use a negative sign. You say minus 5 minus, you press everything it is. How much you get when you use the negative sign? Yeah? Or negative 3 over 2. Sine theta equals to negative 3 over 2. So let us focus here. Let us focus on sine theta equals to 2 over what? 3. Sine theta equals to 2 over 3. What are we dealing with? We are dealing with what? General solution. We are dealing with what? General solution. And when you are dealing with general solution, it's important to find, pay attention, to find what? The reference angle. How do you find the reference angle? You say second function of sine, 2 over 3. Well, how much is my reference angle? How much? 41,81. This is just a reference angle. We will see how to use the reference angle. The first thing that we do is to find the reference angle. Another thing, pay attention. You look at this trig ratio sine theta. It is 2 over 3, and this 2 over 3 is positive. Do you see it? Sine theta is 2 over 3, which is what? Positive. It means our angles lies on the first quadrant and in the second quadrant, because that is where sine is what? Positive. If you remember your cast diagram, all student takes copy. Sine is positive in the first and in the second. So it means that in the first quadrant, we are going to use this angle, this reference angle, 41,81. Obviously, it's in the first quadrant because it's between 0 and 90, where k is the element of integer. Theta equals to another angle I'm saying is in the second quadrant. How do you find the angle in the second quadrant? You say 180 minus the reference angle. If you add, you'll come to the first quadrant. Don't add. You say 180 minus so that you get into the second quadrant. 180 minus 41,81. I see 39. I see maybe, how much is it? 38,19. I'm just guessing. 138. 138, oh yeah. 138,19. Plus k times what? 360. K is the element of integer. Let's just stop here. I wanted to do two problems, but unfortunately we could not do both. So I'm going to give you one as your homework. Cos 2x equals to cos x plus 2. Cos 2x equals to cos x plus 2. I will check it tomorrow in the morning before you enter the class. That will be your, if you don't have it, you won't have access to the class. I'm not